Okay.
So in this video we will look at 1634, which is asks us to show how ethyl phenylketone could be synthesized from each of the following. And part A is benzene. So want to convert benzene to ethyl phenylketone. We can do this using a Friedel-Crafts acylation with this acyl chloride and aluminum trichloride. So part B is a benzonitrile. These nitriles can actually react with Grignard reagents to produce ketones or produce a carbonyl instead of an alcohol. So we can react this with ethyl magnesium bromide, followed by an acidic aqueous workup. And that will convert the nitrile directly to our ethyl ketone. So part C is benzaldehyde. And again, we can do this with Grignard reagents. Ethyl magnesium bromide. Giving us this alcohol. And we can oxidize the alcohol to the ketone using PCC or chromic acid and acetone. So that gives us how to convert benzene, benzonitrile, and benzaldehyde to the ethyl phenylketone. That this conversion of nitriles to carbonyls with Grignard reagent is useful to know. So we'll go ahead and move on to 1635. Which states, show how benzaldehyde could be synthesized from each of the following. Part A. Benzyl alcohol. So we want to convert benzyl alcohol to benzaldehyde. And we can do that by oxidizing the alcohol. PCC is one way of doing that. Now we want to, in part B, we want to convert benzoic acid to benzaldehyde. Now we can't directly reduce the carboxylic acid to the aldehyde. We have to convert this carboxylic acid into something else that can be converted to the aldehyde. And one way of doing that is to convert this carboxylic acid to the acyl chloride using thionyl chloride. And then to reduce that acyl chloride using lithium, aluminum, tritert butoxy hydride in diethyl ether at negative 78 Celsius. And we can get the aldehyde. Now, another way of doing this might be to use a strong reducing agent, such as lithium aluminum hydride in diethyl ether, to go ahead and convert that carboxylic acid all the way to the alcohol. Then, to oxidize that alcohol using PCC. So part C, phenylethine is our starting material. So phenylethine to benzaldehyde, and one way of doing this is with if we oxidize this triple bond with potassium permanganate, followed by an acidic aqueous workup. And we can convert that triple bond to the carboxylic acid. Then, just like in part B, we need to convert that carboxylic acid to the acyl chloride. And then we can reduce the acyl chloride using lithium, aluminum, tritert butoxy hydride, diethyl ether, -78°C, to get the benzaldehyde. Alternatively, I think we could convert our triple bond to a double bond using hydrogenation in Lindlar's catalyst, or the P2 catalyst, so that we get an alkene. And this is styrene, by the way. And then the styrene could be reacted with ozone, followed by dimethyl sulfide, to split this double bond and convert each to carbonyl. I think this would be another method of converting the alkyne to the carbonyl through this alkene intermediate. So part D, is phenylethene or styrene. To benzaldehyde. And so one way of doing this would be to react our styrene. You can oxidize that with potassium permanganate. Convert that double bond to the carboxylic acid. Then once we have the carboxylic acid, react that with thionyl chloride to produce the acyl chloride, and then use aluminum tritert butoxy hydride in diethyl ether, -78°C, to produce benzaldehyde. Oh, I didn't show any of that, so I'll go ahead and move that up to the where it's visible. And I think another method would be to borrow this conversion of styrene to benzaldehyde using ozone and dimethyl sulfide. So part E, we have an ester, a phenyl methyl ester. We want to convert to benzaldehyde. We can do that using diol H at -78°C, followed by an acidic aqueous workup. Actually, I think we can do that with just water. We don't need the acid. And that will convert the ester to the aldehyde. And part F, we can fit this in here. Benzonitrile can also be converted to the benzaldehyde using diol H -78°C, followed by water. So we'll go ahead and stop this video with those two problems.